All right. Sorry for couldn't delay anything.
Okay, wanted to say a few words about his implementation registration process.
Okay.
So I was thinking after my section.
Yeah, slot it in whenever you think at the end is fine.
Well, it doesn't have any slides, but it's good
Yeah,
to
so
hear about
yes,
it.
definitely. Yeah. Oh, hang on. Is there another chain? So if I, wait. Okay. Yeah, if we can somehow get them at a suitable moment onto this laptop, we can do that. But yeah, we need to get started. Who's going to do the honors?
Okay. Good afternoon. This is the DNS Service Discovery Working Group. Tim and I are the chairs. Next. Okay. Oh yeah, right. And next. And this is the new Noel, right?
Yeah.
Here's the
179.
I didn't do the diff. I don't know if anybody has, but it's there.
It's 8179 is the new thing.
Ah, okay. I'll give you a minute to absorb that.
You still have the right to remain silent.
Everybody scroll down to the bottom and click I accept. Okay, next, please. Do we have a Jabber Relay volunteer? Great, thank you. And Tim, Tim, the hero of the revolution, is going to
Not that hero.
is going to take minutes for us. And feel free to jump in on the Etherpad and put your own. If you.
I already updated the current agenda.
Oh, great, thanks. And if you know a name that we don't get in or something else gets missed, feel free. It's a collaborative effort.
Cool.
Okay. Yep, the stuff you find when you go to the data tracker. Here we are. Next.
And the next one, you've got some.
Yeah. Do you want to?
Yeah. Okay. So this is the data tracker screenshot showing the status of the various documents. So we'll talk about some of them today, but the requirements has obviously been published for some time now as an RFC. Hybrid we'll come on to in a moment. There's just a couple of things that need doing there as discovery proxy, as it's now called, before that gets pushed up towards the ISG. The MDNS interop is in the RFC editor's queue. I don't think it's popped out yet, but it must be very imminent. We'll be talking about the pairing and privacy drafts today. It's the first item on the agenda. And then push is also very close. I think Stuart's just got one kind of key question he wants to ask the group about the change that's made to the last version.
Oh, good. Tim Wasinski. I'm writing the Shepherd thing for push.
Yeah.
Somehow you guys put my name on it, which is interesting.
Oh, sorry.
And it's basically all done. It's sort of getting all the formatting because I've wrote a bunch of stuff about the normative download references around the session signaling thing, which has been just a good time for us in DNSOP. So that's the only thing. So you should see that by the end of the day. Modular, what else I got going on? Okay.
Sorry, apologies. I thought we'd had a discussion.
Oh, yeah, we did. I just,
Oh,
so
okay.
I want you to give you a hard time.
That's all right. Absolutely fine. So, yeah, the goals today, hopefully finalize the submission, what we need for the submission of the discovery proxy and push, although we still have this dependency on the session signaling, as mentioned. Discuss the Dnssd privacy draft and the outcome of the working group last call that we did. There are a couple of comments on that that I think have been addressed, and the device pairing draft. And then go through the various first drafts of the future work agreed last time. And Stuart's got a slot for that today. And then the final thing, we've got about 15 minutes or maybe a bit more at the end. We'll see how time goes. Just to discuss a draft that Kerry and maybe other authors have written over in the core group about the interop between Dnssd and Core RD and potential mappings between the two. So we did discuss that very briefly last time, but there's now something a little more tangible just to discuss. Okay, and here's the agenda for people that have got fighter pilot vision at the back. You'll be able to hopefully read this. So 20 minutes for the privacy draft, some device pairing, 30 minutes for Stuart to talk about a number of the new items. Ted then got 15 minutes on the MDNS relay, and Kerry 15 minutes on the Dnssd RD interop. Okay, not seeing any violent disagreement, that's good. So just one quick slide on the hybrid proxy draft. It might be that Stuart has something in his deck about this as well. Essentially, the 06 update was published some time ago. It was renaming the hybrid proxy to discovery proxy as we agreed. That's up there. It's just I've done the Shepherd report. There's just a couple of things to iron out. One is changing the reference from .home to .home.arpa. And secondly, there's a little bit of confusion, it seems, over the IPR statement, but I had a discussion on that with Stuart, and we just emailed the Secretariat to check what's going on. It looks like they might have erroneously withdrawn the statement on this document when they were withdrawing on the requirements document that originally erroneously had the IPR statement on it. So anyway, we're in touch with the Secretariat, and hopefully we'll resolve who had that removed and then take it from there. Okay, and then DNS push, again, I think Stuart might be mentioning this in his deck. There was a very small number of changes going to .-12, which is the version we intend to push upwards. And I've just emphasized in bold there the main difference, which was allowing the client to talk to its normal DNS recursive resolver, or try to talk to it first before talking directly. But I think Stuart might come on to that later, so heads up on that one. Okay, so that's it for the introduction. So first speaker, I think, is Christian, or is it Daniel? Christian to.
And Christian, before you start, I have an announcement. This is going to be my last meeting as working group co-chair. I'm going to step down. If you're interested in becoming co-chair of the Dnssd working group, working with this guy who makes it all very easy. It's really a pretty straightforward working group to manage and run. Please contact either myself or Tim or our fearless area director, Terry. Thanks.
Have you thought about reconsidering your option? No. I'd just like to say thank you. Thank you for the effort. You've done a wonderful job. Over the last couple of years, this has been one of my favorite working groups.
Wait, you said that about mine.
I said one of.
Yeah, this time he meant. Oh, okay.
Thank you, Terry. Thank you very much.
It's okay, Ralph. No. You guys do good work.
Christian.
Okay, good afternoon. So Dnssd privacy and Dnssd pairing, it's an effort that started 2 years ago, and which we hope is on its concluding stretch now. Summary, for those who have not read the draft, that's a summary of the DNS privacy enhancement. The idea is that instead of discovering directly by asking what you want, you do a rendezvous on a pseudonym, and you open a secure channel, and then the queries are sent over the encrypted channel so that nobody can read what you're doing, and nobody can guess who you are. So it's simple enough. What have we done since last time? We worked a lot on the prototype implementation. We had a couple of reviews, detailed review by Stefan and by Ted. And thank you, Ted. Thank you, Stefan. We published a revision that answers Stefan's question, I hope. We have not published a revision answering Ted's question yet, because, time. So I have here a couple of issues that Ted raised, and I thought it would be good to review them one by one, because, I didn't review everything. Some of Ted's comments are basically things we're going to just fix, and there's no point there. But some we need to maybe explain a bit more. The privacy exchange rely on a shared key between pairs of hosts, pairs of nodes. And Ted was asking the questions, hey, why don't you guys use public key technology? It seems more modern. And it was actually a very deliberate decision, is that public key technology means that your public key is an identifier. And the public key exchange is very hard to do a public key exchange that does not disclose the public key. And so if you are trying to do privacy, public key is not necessarily the right fit, not immediately. So that's the reason why. I mean, the other thing is that a private key exchange that is known a shared secret between two nodes, when it is used, provide an immediate verification that you know who is the other guy. So you know what to disclose. Whereas with a public key, I mean, you would have to have a pair of public key exchange to do that. And so Ted's comments is welcome because it will force us to check back the text that we have to make sure that we explain the rationale properly so it's not ambiguous. Yes.
Carsten Bormann. In the IoT, we repeatedly run into the problem that we need a secret handshake.
Yes.
Where we have a member of a group that tries to ascertain whether somebody else also is a member of the group.
Yes.
Without either disclosing that they are a member.
Yes.
Or it also can be two groups.
Yeah.
Is that something that would be useful here?
Well, that's what we do.
Okay.
That's what we do. Okay.
It's part of the same.
Second issue that was raised by Stefan. We make the rendezvous operates on a name. It's basically the way you do secret handshake is that you have a nonce and a shared secret, and you compute a hash of that, and you verify that they both know the hash and that match what you expect. And to simplify the protocol, we decided to make the hash the nonce a function of the time. The value of making the hash a function of the time is that both ends can predict the nonce. And so if the nonce is, say, the time rounded to the next 5 minutes or something like that, that means that you have only to do a computation of this hash of nonce once every 5 minutes. Whilst if you let the nonce be a random thing that anybody can choose, you open yourself to a potential denial of service attack that in which someone sends you lots of different nonce and force you to compute lots of hashes and depletes the battery of the small device or whatever. So that's the reason why we chose that. What Stefan was pointing is that there is an edge condition there when you're just at the end of the 5-minute interval. Like within the 5-minute interval, yeah, you can be, your time synchronization needs to be just as good as say 1 minute or something like that. But yeah, at the end of the interval, people are going to switch from this slice of 5 minutes to the next slice of 5 minutes. And if you're not careful, I mean, one will believe that they are before, the other one will believe they are after, and they won't get too much. In fact, it's something we thought of, and in fact, in the prototype implementation, we had a fix, but we did not document it properly in the text. So we fixed that in the version 2 by saying, hey, what you actually do is that if you're at the end of the interval, you also consider the next hash. And if you're at the beginning of the interval, you also consider the previous hash. And that way you eliminate the edge condition. So we documented that in draft 2. Third issue that was raised by Ted is that, hey, this business of updating your hash at a short interval, that's fine when you're doing broadcast because there is no state and nobody cares. It's a bit more problematic when at the end of the interval you have to push an update to a server. Because if you end up pushing frequent updates every 5 minutes to the server, then you'll have server overload. Not to mention a peak of load at that exact time.
So this is Ted Lemon. That's not actually exactly what I meant, although that may be what I said.
Okay.
What I was concerned about is not so much load on the server, which I don't think is really a serious issue, but rather that the caching behavior of a Dnssd client will be such that it will remember records for longer potentially than the lifetime of these. If the lifetime of these things is only 5 minutes,
Yeah.
a record might be cached longer than 5 minutes. And
Well, we
unless there's a
obviously
problem
we'll
with
set
that.
the TTL to 5 minutes, but yes.
Well, right, but I mean, is there any particular reason to not have it be more in line with, because DNSSD and MDNS in particular do a fair amount of work to avoid retransmitting data that's been transmitted multicast recently.
Yes.
And when you tune things up so that you have to multicast more often, it's really not that good of a thing to do. So.
Yes.
Unless there's a serious, and the reason why I made the suggestion is because I didn't really think that there was a serious risk of replay attacks that would be mitigated by making the interval 5 minutes rather than 30.
Well, you have 6 times more chances to get a replay attack in 30 minutes than in
Right,
5.
but what do you get if you do a replay attack?
So basically, what you get with a replay attack is that you can discover whether someone is at the location.
Yeah.
So the concern we have is that someone listened to a hash to one of those nonce at one location, and then replace it at another location to see whether your body has moved to that other location.
Right.
That was what we were concerned with.
Yeah.
So basically, if you make that valid for say 1 month, then you have a real problem because you track someone all the time.
But
Okay.
30 minutes.
If you make it, you suggest 30 minutes, and that means that basically I'm exposed that if I move to here to someplace else in 30 minutes, that move might be discovered. Now, of course, in 30 minutes, I can only move in the next town, basically. So yeah, that risk is only to that level.
Yeah.
That's what it is.
Yeah, I mean, there's. It seems like there are some attacks that you can do that if you have that degree of control over the network infrastructure and a whole bunch of different hotspots in various places, there are a lot of games that you can play to know that not so much know that a particular device has moved, but if you know about a number of devices and you can watch them looking at each other, then you may be able to learn a fair amount about their associations by having this kind of overview that you're talking about. So that seems to me to be a bigger risk actually than this.
It compounds it actually.
Yeah.
It compounds it.
Right.
So it's a classic premise. That if I have one leak, shall I plug the other leak, and at what cost?
Yeah. So the problem is that you're pushing potentially a fair amount of data in these pairing, or not in the service discovery part of this. And so there is a trade-off being made here.
Yeah, and as I said, I mean, I'm not opposed to moving from 5 minutes to 30 minutes.
Mm-hmm. Yeah,
it's just a different trade-off, and if
what
people
I
feel
would
comfortable with that, I'm fine.
What I would actually suggest is that if you're using the registration protocol, 5 minutes is fine because it's all unicast, and I don't care. The load on the server isn't that much. If it's multicast, then I would want you to use a longer interval because the load that you're creating is larger. You see what I mean?
Oh, you're thinking, I was concerned with the opposite, yes.
Yes, yeah. In the multicast case, the load on the network is increased by shortening the TTL. In the unicast case, who cares?
Okay,
So.
Fine. I would rather do it in all cases then, but yes.
I had a small concern about the previous slide, the 5 minutes interval. Hi, I'm Anshul from Boston University. So this is timing based, right? I'm just a little concerned how this will be implemented. Is it implemented as a counter or as an absolute time?
Absolute time.
Which is really bad because if you can change, if there is a difference between times, then you can again, like if you can change, move the clock by 5 minutes or 5 minutes, then you can again do the same DOS that you're preventing it.
Well, yeah, it only works if if we choose an interval, be it 5 minutes or 30 minutes, then we require that the time synchronization will be better than that.
I mean, is there a reason why we can't implement it as an counter?
Yes.
That'll be better, right?
No, we cannot. It's because you don't have a common counter between the two stations. You have to do a prediction and you have to make it variable over time and etc.
But I think in terms of time, it's a little.
No. The alternative is to have a random number that changes all the time, but then you have no caching property, and then you have a risk of an exhaustion attack by having multiple random numbers.
Yeah, I don't know what the right metric should be, but I think time is it's just 5 minutes. Like you can, how is time updated? It's NTP, and you can attack NTP.
Look, I mean, if we take, suppose that we adopt Ted's suggestion to make it 30 minutes instead,
I mean,
then,
that doesn't help.
clearly,
Yeah.
clearly, on time synchronization, you have to be really bad to make it not work. Okay.
Also, the overlap interval, like how does clock drift? Like there's some small interval, right?
No,
There's a small interval when it accepts both.
Yes.
And yeah, it's like depends on the quality of
Yeah.
clock. Like
yeah,
it could
yeah.
be way.
No, I mean, okay. If you are really concerned about time synchronization, we can take a larger interval and it solves both concerns. That's fine. Yeah, but
Yeah, thanks.
Jabber relay. So.
Yeah. Oh, no, I was getting renamed.
Oh, okay. Sorry. Okay. Sorry. I thought you had a message from Jabber related to mine. Dave Taylor. So if there are use cases that are important where, say, one end does not have a source of absolute time. I don't know if there's some, IoT case. I mean, Stuart was arguing the other day about, using Dnssd for, constrained environments and things. If there is a case, have you actually looked how much weaker does it get? And I'm not saying you should do this. This is actually a legitimate question. How much weaker does it get if you had a way for the requester to put in its guess as to what the absolute time is, which should be public information because everybody really ought to know that, right?
yes.
And if the receiver then just simply trusted that, because that's not the only thing it's computing the hash over, how much weaker does the crypto get is my question.
In fact, the time that you believe, the value of the interval that you believe in, is the first 24 bits of the token. So in the protocol, as we broadcast those tokens, you will learn what the other guy believes the time is. So you could do this.
So
kind
what
of
I'm saying
hacks.
is if the receiver of the query, for example,
Yeah.
had no clock and it just took whatever the requester said was the absolute time, does it actually weaken the privacy promise is my question.
Yes, it does.
And how much weaker does it
it
get?
exposes you to replay attacks.
I don't know if it already does, but calling that out in the privacy consideration or in the security consideration section is probably a good thing because that might become a frequently asked question.
Okay.
Or perhaps, if you want to use it for that, here's what you lose, right?
Yes.
Stuart Cheshire from Apple. I just wanted to thank Anshul for her comments and explain a bit of background, which probably other people in the room wouldn't know. It's very easy for us to say, well, we assume the clocks are synchronized. And Anshul has spent a long time working in the NTP working group, working at how to synchronize clocks securely.
Yes.
So there's a lot of thorny issues here. And I think it's worth discussing. Probably not, we shouldn't rattle on it right now in this meeting, but I do think it's an interesting area.
And again, I mean, what we may want to do is what Dave suggests is having in the implementation consideration, what happens if your clock is not properly synchronized? Yes.
Yeah, that sounds good.
Okay. Fine. So we'll lean towards the longer intervals and we will add the consideration. Now, another comment that Ted made is that when a device advertises itself, it advertises the list of instances that are present, which is effectively the list of pairing. And the number of pairing in this list is a property of the device. So whether you have 11 or 7 or 12 can be used to kind of identify you. And Ted's suggestion was, should we do some kind of fuzzing there to break that kind of fingerprinting. And it turns out that in our prototype, we actually do that. So yes, again, that's something that we can document in the security section as one of the mitigations. It has about zero cost, because I mean, you just add a couple of random numbers at the end of your thing, and people will compare them, but it's just a number comparison. It doesn't increase the cost widely. So we'll do that. Another suggestion was, hey, we are doing discovery there for services, and it's all about instance name, DNS SRV records, and things like that. What about applications like SSH that are basically just using the host name? And in fact, again, that's something that Daniel implemented in his prototypes. What he says is basically what you do is that you discover the privacy service, you verify the IP address of the privacy service over the secure channel, and you tie that IP address to host.private.local or some such name that can then be used as a host name basis. And he has implementation of that. So it's probably something that we have implemented, that he has tested, and we can document. That's okay. So that's pretty much the end for the privacy document. Basically, all the comments I've seen, except for the change in time, are kind of editorial in nature. And
clarifications maybe and
yes,
that type of nature, I think, yeah.
So, I mean, they fit in the kind of stuff that you shall do at the end of the last call. So I think that pretty much that means we have to answer the comments. We have to do another draft to answer all of those comments along the line of what I described there. But pretty much we are done there.
Yeah, I think so.
Yeah. The pairing draft, Dnssd pairing, basically discovery relies on those shared secrets, and we wanted to have at least one method of establishing those shared secrets. So we have the pairing draft explaining a method which is in 3 phases. You do discovery using MDNS or Dnssd, and you use a key agreement protocol, which is, in our case, just doing a TLS anonymous connection. And then you do a key verification in which you extract the negotiated key from the TLS context, and you use, basically a commit-based, a commit-first protocol to make sure that you can verify that computer hash on both sides and print out a short string, like the first digit of the hash, on the screen, on each screen or in each display. And then you verify that those displays match, and it has good cryptographic property. It's a well-known algorithm. And once you have that, if both ends up verified that it matches, you can remember the secret and use that forward. So that's very straightforward. There's no difficulty. It can be implemented in a very simple way. So the problem is that we had very few reviews. We had a review from Steve Kent back in January, and it was nice. He gave us a lot of feedback, but basically Steve was said, yeah, it's fine. The document is fine. And then
I just want to clarify, I'm not falling asleep. That's supposed to say pairing, not privacy, right? Is that a typo?
Yes.
Okay.
Oh yes, yeah. I'm kind of slow.
Christian's testing you.
Yeah. Thank you. So basically, we had very few reviews. And after Steve Kent's review, Ted was the next one. So we did a revision before that with mostly clarification based on own proofreading and all that. But the Ted's review requires first a couple of clarification, and I'm not going to go into the clarification. And then 2 big suggestions relative to QR codes and to analysis and spec. So QR codes. In our draft, we propose an option to use QR codes as a way to speed up the user interface. The QR codes are grafted on top of the previous protocol. We can use one QR code as part of the discovery, in which instead of doing a network exchange for the discovery, you read the QR code, and that gives you a unique private name that you can discover safely. And at the end of the exchange, instead of manually reading the number on the other screen, you read the QR code and then you compare it to what you have on your screen. So it's really UI source on top of the existing protocol. And that's point out that it feels like a separate thing. It should be separated. And at that point, I have two options. I mean, and I would like to get feedback from the group on those two options. One option is to leave it in the document, but maybe move it to another chapter of the document. Says, hey, if you can read QR codes, you can do this, and that will make your UI simpler. So it's one option. And the other option is to remove it completely and do that later in another document. And frankly, I would like to get feedback about what people prefer.
I think there's another question about splitting the document as well. So maybe
that's really the next question.
Yeah, maybe come on to the next one, and then we have a discussion about all the splits that might happen.
Okay. The next one is that the pairing document it's kind of long. It has almost 20 pages, which is basically 16 pages of analysis and 2 pages of spec. And Ted was saying, hey, you know what? If you put the spec in a very short RFC, I mean, I can give that to a developer and says, can you do that? And I say, yeah, sure, I can do that. That's easy. Because it is in fact easy. It's literally maybe 200 lines of code. Okay. And on the other hand, if I give him a 20-page document, which goes into a long discussion of the academic research on the subject, he'll be scared and he'll say, I need to analyze that. I need to understand that. Let me read that for a week or two, and then I'll tell you. So Ted's suggestion was, say, split the 2 drafts, put the analysis in front in one draft, in one informational RFC, and put the specification in a short standard RFC, which is simpler and will be implemented quickly. And will have less, will guarantee more interoperability. And actually, Steve Kent made the exact same suggestion. We delayed that because the feedback in Chicago was, say, wait a bit until we do that. But I can definitely do it. The problem was that if we split the document, we have to redo all the last call and all that. But so be it. Okay. So that's pretty much where we are. And the next step is basically, my understanding is that the private discovery draft is basically ready. That's no question. Yeah. But for the pairing, we need to have this split, and we need to decide what to do with the QR code. And we probably need a second last call with the result of the split.
I think that's a really good summary there, Christian. So produce the 03, I think it is, for the privacy, and check the people that made the comments are happy with those resolutions, and we'll push that up. On the pairing, I think Steve and Ted have both made the comment about splitting it, and I think we're on the fence, so to speak, about that. I think your comment about making it as simple as possible to pass to someone to implement is actually a very good one. So they're not going to be put off by a lot of discussion and analysis in there. So personally, I'd be leaning towards the split, possibly both splits, but it'd be interesting to see what Ted and Kerry think on the mic line.
Ted Lemon. So I actually read the doc. I deliberately did not read sections 2 and 3. I saw the thing in section 1.2 about the rationale for maybe splitting, and I thought, well, let's test this. And so I just said, okay, I'll start with section 4. And I read section 4, and I was like, wow, this is really easy.
So you're happy at standalone with 4?
So I just think it would be a shame to not capture that experience for other potential users of this document. The explanation of the theory is really great. Like, I really enjoyed reading that. It was very helpful. So I don't mean to say that it's not useful. I just think that if you put it in the same document, you're running the risk that somebody's going to do exactly what you said. They're going to look at it and they're going to say, ooh, this is hard.
And I think the other comment I'd make here is we're not rushed for time to get this through because something else is depending on it. So we
Right.
can take a little extra time to split things
Yeah, well,
out as
the
long as
privacy draft
Christian's
is
happy to
quoting
do
it,
that.
but it's not.
Yeah, yeah.
On the topic of the QR code, I think the idea of actually separating that out into section 5 is a good one.
Yeah.
My main concern about the QR code is actually that the UX isn't very clear. Like it would be good to actually have a little intro section in section 5
Yes.
that says this is what the user will do, because
Yes.
you know, I can tell you what the user will do. I've read the document,
Yeah.
but it's not entirely obvious, and the UX is actually a little weird.
Yeah.
And I think you really have to want privacy to want that UX.
Yes.
So if you really want privacy, then yeah, absolutely, it's nice to be able to just take a snapshot of the SRV record.
Yeah.
But if you don't, like, it's going to be really hard to explain that to somebody who's not savvy about security.
Yeah.
And the thing that you lose by not doing it is relatively, you know, it's not a thing that I would be concerned about personally. I mean, you know, there are lots of ways to do pairing that that are reasonably private.
Okay.
Carrie Lynn. Christian, I was wondering if you were aware of the EAP noobs proposal that was presented in the T to TRG summary working group or research group the other day by Mohit Sethi and his collaborators. But it basically is based on this idea of using dynamic QR codes for network admission control. And so I don't know if there's some maybe shared primitives and particularly shared UX that you guys could potentially talk about. But as we, try to package this stuff up for, just unsophisticated users, it'd be really great if we could come to some common operations that they learn
Can
how
you
to
send
use.
me a pointer to the document?
Yeah,
Because
sure.
The minimum I can do is a quotation. I mean, and say, hey, it's also done there. I mean, look at the
Yeah,
UX
but
version.
you two might want to get together and chat if you can.
Yeah.
Okay, thanks.
Okay, thanks, Gary. Okay, if no one else is coming to the mic, I guess we could take the feeling of the room on the two separate splits. So,
I don't know whether Daniel is hearing us, but if he wants to comment.
oh, okay.
No, it's not going to the mic.
Okay, so those in favor of splitting out the problem statement stroke analysis from the spec in the pairing document, please raise. Please don't raise your hand.
Yeah, Daniel Kaiser on one of
Come closer to the mic. You're a little.
I am.
Yeah,
I am.
but okay.
Okay.
He has to use the tool.
Yeah.
He has to raise his hand on the Meet Echo. There's a raise hand icon you have to click, and then your Pac-Man comes, and then we press a button, and then we check the QR code, and then we let him in. Okay, so give him another 20 seconds.
Okay.
Oh, yay.
Yes.
Press the red button, Ralph, for the last time. Or was it too soon?
Oh, I thought you hit the code.
Maybe press a...
You might be muted, Daniel.
Hello.
Yay!
I just wanted to say that I can hear you. It's like all I wanted to say because you asked whether I'm listening. Yeah, I am.
Well,
And do you agree with the proposed resolution
Our
of splitting the document, splitting the
Yes.
analysis, and splitting the QR code in a special chapter?
yes, I think that's a very good idea.
right.
Okay. Okay.
Okay, so we'll take the... Do we have to press the button to cut him off as well? Or...
Yeah. Okay. Well,
Right, bye. That's so fun. Right, so all those in favor of splitting out the problem stroke analysis bits from the solution bits, raise your hand. Yeah, separate document. All those who think it should stay as one document, raise your hands. Okay, and all those who are reading email, raise your hand. Okay, so that was about 10 for and 1 against. So I think we say go ahead and do it. I'll just do a check on the list, maybe just to confirm over a week. Okay, so yeah, and to put the QR code in a separate chapter in the solution bit. Yes, is that what we said? What was the proposal for the QR? We need to have a check on that.
Yeah. Well, I I would rather not do a separate draft for the QR code because the QR code is really a layer of UI on top of the.
But it's in the solution document.
So I mean, I don't want to multiply the number of documents either. So
Yes, well, we're not in danger of running out of RFC numbers yet. So. Are we? Oh God. Oh really?
Oh yes,
Oh.
yes. You know,
Yes, you should-
you know about the RFC 10,000 bug.
I've just heard about it about 5 seconds ago. Oh my God. You're getting out just in time, Ralph. What was the question? Yeah, so I think we probably ought to take the feeling of the room about what we do, Dave.
I think you should ask it 3 ways. And
Okay.
not just 2 ways, right?
Yep.
Because you can leave it as it is now. You can move it as Christian's proposing, or you can split it into a separate document. I think the example that Kerry gave is a possible argument as to why a separate document might make sense if you would tend to say exactly the same thing about the UI as you would in the other draft and maybe a third one and so on.
Yep.
So I don't know if there's value, but there's value in asking the question that way to see what everyone thinks.
And what was the third option?
Separate draft, separate chapter, and exactly how it is now, and no change.
Okay, right. So let's go through those 3. So all those in favor of leaving it as it is now, raise your hands. All those in favor of putting it into a separate section in the existing document, raise your hand. 2, 3, 4, 5, 6. All those in favor of putting it into a completely new document and exhausting the RFC numbers, raise your hand. Okay, so that majority was it was 171, I think there. So separate section in the same document. Great, thanks very much, Christian.
Thank you.
So next up is Stuart. And we're on the PDF, weren't we? Well, and then full screen.
Yep.
Cool.
Thank you. I'll stay in the pink box. That 20-minute session turned into about 45. So I will go through this really fast because I want to leave time for the other agenda items that are
We're
important.
only about 6 minutes behind. It's okay.
Are we?
Yeah.
Okay. So a bit of a reminder about why we're doing this, because we have multicast DNS. Multicast is expensive or unreliable or both on many newer network technologies. On the old coaxial Ethernet, you stick the vampire tap in and all the packets go everywhere anyway, so it doesn't matter. On Wi-Fi, as we've gone to higher data rates, multicast has not kept up. So the disparity between unicast and multicast has got much bigger. A battery saving on phones and tablets has meant multicast is much less reliable on Wi-Fi. When we have more complicated home network topologies that aren't a single link local multicast doesn't go everywhere. When you have mesh networks, like 802.11s, supporting multicast reliably is very cumbersome. And of course, on enterprise networks, most enterprise networks, I would say today, just block multicast at the AP. So there's a number of reasons we want to get away from depending on multicast. Quick status summary. Ted and I have been working hard, and we got out 4 brand new documents before this meeting. And there are now enough documents that unless you've been following this from the start, it's not clear how they all fit together. So that really called for a roadmap document. And I will talk about these others in a bit more detail. We have a way of registering instead of using multicast. We have the broker, which provides layer of indirection for the discovery proxy. And we have something that Ted came up with, the idea of a relay that is a complement to the discovery proxy. 3 of our documents have been updated. Minor updates. The discovery proxy document is basically finished, not expecting any changes. There is this issue about updating the reference to .home, which is a trivial change. It depends on push, which depends on session signaling, which is currently still being debated, and we are trying to push that along. But that is where that sits right now. 2 documents were not written. And as a result of the discussions with Ted, he has kind of talked me around to the point of view that we don't need these. And that's why I'm mentioning it, to get the sense of the room if other people agree. The advertising proxy was conceptually the mirror image of the discovery proxy. The discovery proxy is what lets a remote device say, I'm not on that link over there, but can you do discovery for me on my behalf? The advertising proxy would be the counterpart, where a device offering a service like a sensor or a controller like a light switch could say, I'm not on that network, but can you advertise this service that I provide using multicast? And a related issue is when you have multiple links in the home, you don't want the names to be duplicated, so we want a way to deduplicate the names. And Ted made this point that we're doing all this work to move away from multicast because there are a number of reasons it's not just desirable. So do we really want to put a lot of effort into perpetuating more use of multicast? And when he put it that way, I thought, no, we don't. So unless other people feel strongly, my feeling right now is we should drop this and really consider, I'm seeing nodding from Dave Thaler there, so that's good. We need to support multicast for the 15 years of legacy devices that we already have on our networks. But moving forward, I think we should be encouraging unicast registration as a much more efficient and reliable mechanism for the networks I just talked about.
So I don't want to rat hole on it now, but at some point I'd like to hear more about how to deal with legacy devices. But
Okay.
but not now.
That's actually a good question because that's about what I was going to get into. I even have pictures. Okay. So because of all these little pieces, I actually think it's good to break independent things into separate documents. Ted made the comment that if you want an implementer to look at something that seems small and approachable is a lot more attractive than a 100-page spec they've got to wade through. So where things do naturally decompose into modules, I think that's great. But knowing how these Lego blocks stack together then becomes the challenge. So I have taken a first cut. This is just a draft 0.0, but this is a start at doing the roadmap of how these fit together. And this is a few pictures to elaborate on that. So a client gets a configuration from the network. Here at the IETF, the network is telling your devices, you should look in meeting.ietf.org. The mechanism for that is in RFC 6763, so I won't spend time repeating that now. But the client gets configured automatically, or you can do it manually if you want to type it in. How that happens is a separate question. But once that is done, the client then follows those instructions and it says, I'm going to query link1.example.com. Well, the normal DNS, NS record delegation hierarchy tells the client that this device on the network is the authoritative server for that domain name. So the client sends its query there. And the discovery proxy, instead of consulting its own file on disk like a normal DNS server, it uses multicast queries to find the answer to that question, gets the replies, sends them back to the client. So this is the basic motivation behind the discovery proxy. A remote client can now act as if it's local, and the proxy will do the queries on its behalf. The client can be configured to look in more than one domain, which has a number of useful applications. So you might tell it to look in 3 domains, and it will then query 3 links, 3 different discovery proxies, and discover 3 different sets of servers and get all of those results back and present them in the UI. This is done and implemented today and works fine. When you have more clients, all of the clients are talking to all of the discovery proxies. And if your discovery proxy is a little bit of software built into your Wi-Fi access point, it may not be engineered to handle thousands of connections. And the clients, if they're battery powered, may not want to have multiple connections. So the solution here, before I get onto that, little tidbit I wanted to point out because it may not be obvious. Clients don't all have to query the same 3. So a client here might be directed by the network to query 3 different links. And a client here will query links 1, 2, and 3. And a client here will query links 2, 3, and 4. So if you had say like a long narrow building, or maybe a circular building that's sort of donut shaped, then the clients in each segment can be directed to the network to query their segment and the two adjacent ones. So you have a kind of sliding window effect that you're discovering things that are nearby, and you don't have the issue that if you happen to be right at the edge of your segment, you're not finding the thing 10 feet away because you've got this +-1 overlap. But let's go back to my simple example where all the clients are querying everything and you've got this big mess of connections. This is where the discovery broker comes in. Instead of telling the client to look on this link and this link and this link, we say you just look in services.example.com. And the authoritative server for that is the discovery broker. And where it gets its answers from is not a zone file on disk, and it's not multicast. It is unicast DNS queries to the 3 different discovery proxies, and then it can amalgamate those results and return them back to the client. And that way, if you have multiple clients, each discovery proxy still only has one connection to one discovery broker, which is a big iron server in the data center, and each client only has one connection to that discovery broker. So it saves battery power on clients, it saves CPU load and resource requirements on the little discovery proxies on the network. So that's the motivation for the discovery broker, is it lets you put a big server in the 19-inch rack and not expect every little access point or every router on the network to support thousands of clients. So let's go back to the simple example without the discovery broker. And the last thing I'm going to talk about now is an idea that Ted had. And like a lot of good ideas, it's one of these things that in retrospect seems really obvious once it's explained to you. And Ted has a long history working in DHCP, and I'm guessing that might have been what inspired this. In the residential market, your home gateway has a DHCP server in it. And coming from Apple with our airport base station line, that's my model of DHCP. It's a thing in the home gateway. But in the enterprise, all the routers on your network run this very lightweight BootP relay agent. And the actual brains of the corporate DHCP server is a big iron server in the data center. And Ted said, why don't we do that? So here, instead of having a full heavyweight discovery proxy on each link, we have a discovery relay, which is like the BootP relay agent for service discovery. And it talks to one client, and that client is the actual discovery proxy. So we've taken this piece of software, the discovery proxy, and split it in half. So it has got this relay agent it can talk to over there, but it does its thinking and logic processing over here. And of course, once you've done that, those 3 light blue boxes on the left don't have to be different bits of hardware. That might just be software running on a single server in the data center. So this is Ted's inspiration, and Ted will be talking in more detail about this later on. So that's the end of the pictures, and I'm just going to run through the rest of what the roadmap document covers and how that relates to the documents. And in my mind, the way I divide this up is in 3 parts, is how data gets into the namespace so that it can be queried. Part 1 is all the legacy multicast DNS devices that we have. And the answer is the discovery proxy is the backwards compatibility story for existing devices, and it builds on these other 2 documents. The relay is not a modification to that document. The behavior of the discovery proxy is exactly the same. The only difference is instead of having a physical EN0 Ethernet interface that it's sending and receiving packets on, it's now got a remote virtual interface, almost like a VPN tunnel to somewhere else. But the behavior of the packets sent and received over that virtual interface are exactly the same. So that's the legacy story. Part 2, looking to the future, is how do we want to do this without so much reliance on multicast? and that is active registration. So to that end, we have a draft 00 on what we are calling the Service Registration Protocol, which in a way is just another name for DNS update with some a profile or set of use cases imposed on it. We use DNS leases as a way to do automatic garbage collection. So if a device goes away, its data doesn't persist forever. Ted came up with a very interesting idea of how to do useful security without onerous configuration, and that's first come, first served security. When you connect a device to the network and it says, my name is X, then if that's the first time it's been on the network and it has physical connectivity on your link, then you say, okay, I trust you. You can register the name X. And along with doing that, it registers its public key, which has a much longer lifetime. That the key might have a week or a month lifetime, whereas the other records are only an hour. If you then turn that device off, it will disappear from your network. It's not there anymore, but its key will linger. And if something else comes along and tries to masquerade as that device, the registration server will reject it and say, no, you can't tell me you're Stuart's printer because I know Stuart's printer and you're not Stuart's printer. Stuart's printer's turned off, right? But I'm not going to let you jump on the network and start capturing those print jobs. So that is described in the service registration document, or at least a simple outline of it. I like that idea because it gives better than no security without difficult keys. It doesn't replace some of the other things we're talking about, like QR codes and other things that may be better. But I think there are cases where this might be an appropriate solution. And then the other optional addition here is the energy saving stuff, because power management is really important in today's world, especially battery powered devices. The whole Internet of Things, home automation, many of those devices, especially door locks, are an interesting example because it's hard to run a power cable through the door hinges. So almost all door locks have to be battery powered.
Thanks. David Skenazi, quick question. Regarding the first come, first serve security, if I have a device that has that name and then I kind of throw it in the trash because it breaks and I get a new one, does that name get stuck forever? Is there a solution to this?
The model there is that you would have to go to the administration page for your home gateway and manually erase the device. So it could not get on the network without you as a human authorizing that exception and saying, yes, I actually do mean this really is my new device and I trust it.
Thank you. That makes sense.
Yeah, Michael Lebrun, same question. Like I have an OpenWRT device at home. I factory defaulted and my SSH key goes away and I have to delete the SSH keys again. So this is a very common case. So whoever makes this administration page device, this should be like, it needs to be pretty easy for people to understand what's going on. And like the failure case, how to make that understandable to the user and how to handle that is interesting.
It would be nice if your OpenWRT gateway kept its SSH private key somewhere that didn't get erased so frequently.
It would, wouldn't it?
It would. Your concern is noted. For many of the devices I have in my house, like the Nest thermostat and the garden sprinkler controller and stuff like that, I'm not in the habit of wiping their firmware on so much of a regular basis as I do with my OpenWRT gateway.
Agreed, but I don't know if there should be a recommendation about this being in. So when you factory defaulted, it keeps its keys. Is there a downside to this? I don't know, but
that's a good point. Yeah.
So Dave Thaler. So on that same point, yes, if you have a home router or whatever, that's not that big of a deal, though you have to worry about how do you scale it up to say, an enterprise or a campus network or something like that. And so I wanted to point out for comparison what Win servers, also known as NetBIOS name servers, do in that case, specifically for enterprises. Because you do have to be able to span, well, it's temporarily off the network or whatever. Right. But I don't remember the exact details, but at the 10,000 foot level, if you haven't heard from it in so long, where so long might be, a month or whatever the policy is, a week or a day, whatever the policy is, then when you need to know, you unicast to that guy's IP address to say, do you have this name? right? And if it's been so long before you've ever heard from him in the past, right? If it's been a month or whatever, and he's not there now, then you do automatic garbage collection and you just throw it out and you pretend that you never got it in the first place. And so it's like having a TTL on that record that says you either have to like ping me or re-register or be on the network when I ask you. And if none of those are true, then you don't need to have to send a
A little
human.
bit like
log.
MLD even.
What's that?
A little bit like MLD, but with longer
Yeah,
time
yeah,
frames.
kind of, right.
Yep.
But you still got to have your timeout be long enough to span, yeah, the device comes and goes, and he comes into the office, he goes away or whatever. So it has to be long enough. But this notion of being able to reach out and say, hey, last chance, anybody there before I garbage collect you.
I like that idea. Thanks.
So this is, widely deployed, and that's been there for,
Yep.
30 years or whatever, so.
Good to know. Thank you.
Julius Krobacek, am I right in understanding that this cannot be implemented if I don't have writable persistent storage? Do I need to put a disk in every single router?
Yes. The registration server I think if you implemented it only in RAM and you didn't have persistent storage that survives a reboot, you would get weaker security properties, right? For as long as you don't reboot it, it would remember the keys. When you rebooted it, it becomes another first come, first serve scramble. And during that window, an imposter could get on your network. So it's a judgment trade-off whether you think that security downside is acceptable or whether you'll pay the extra for a bit of flash storage in that device. I think both work.
What's the intent of the author of the document? Will you send the IETF police to my home if I implement it without persistent storage? Speaking about the
Julie's talking about the registration server. The client can have a factory embedded.
Sure, that's not a problem.
Private key at manufacturing time that doesn't change, but the server's got to remember the public key. I am thinking that our position would be, given that this is better than nothing security, there's a spectrum of better than nothing, and security that has a vulnerability if you power cycle the gateway until everything gets back on the network and reclaims its name. Personally, I could live with that. What do you think, Ted? Yeah, Ted's agreeing it's acceptable.
And especially if that were, especially if that were clearly documented in the specification someplace. Yeah, and right, exactly. We're going to cut the mic line here.
David Skenazy again. So just to make sure I understand this well, what we're deduping on is the name, which is the user visible name.
Yes.
Right. I know of a manufacturer whose name I'm blanking on right now that's making a lot of devices called David's MacBook. If you look at the IETF network, there are a lot of things called that. What if I'm the second one to show up with that? What's the expectation for my device? Am I supposed to become David MacBook 1 and so on and so forth, or something else?
That's a good.
I agree, and if
I'm
if
not
the
gonna
answer
try
is that manufacturer should stop doing that, that could be a possibility.
Thanks for raising that point. I'm not going to try to answer it right now because we'll run out of time. If it automatically renames, then that's one solution, but that's also unpopular if your computer changes its name against your will. So that is a thorny user experience issue. Certainly, if I am connecting for some reason, file sharing, screen sharing, some kind of service to David's MacBook here at the IETF, I don't want to suddenly get the wrong one tomorrow, which is the point of this security. The challenge is that what you want to have happen in your own home and what you want to have happen at a conference of 1,000 people are different, and making that automatic is interesting.
Carrie Lynn, I just wanted to raise the point that came up during the privacy discussion earlier about the fact that this is a persistent identifier that might expose some information. So you might want to at least note that in the security concern section.
Right.
If not, take a look at the secret handshake, sort of technology that we've been discussing in other fora.
Yes, we'll definitely want to check what's revealed. Thank you. Okay, so I said there were 3 legs to this. I've covered the first 2, which is getting data into the namespace for your 15-year-old printer, which is not going to have its firmware updated, getting data into the namespace for the future world of products that don't exist yet. And then once it's in the namespace, the question is, how do the clients do the queries? And the good news is the clients have, for more than 10 years, supported both multicast and unicast querying. So just a quick recap of the documents here. DNS push notifications is a way of getting timely updates over unicast DNS to give it the same timeliness that multicast DNS has, and that builds on session signaling. The discovery broker is this layer of abstraction that lets us do the sliding window around the building and other things like that in an efficient way without n-squared TCP connections. And that is the last of my slides.
Great, thank you. So you've got a couple of minutes for questions. Go ahead.
Yeah, if you go back to the where you added the relay.
On the diagram?
Yeah, where you split that up. You don't have to. I don't think it matters.
Oh, sorry. There we go.
Oh, no, it's not keying up. I'm used to the, okay.
Say stop. Oh, sorry. Yeah, of course, you've got the, yeah.
Where we add the relay.
Yeah, next, right there, you introduced the relay, and then you said that you could like collapse the discovery proxies right there. Yeah. So then what is the difference between the collapsed discovery proxy and the discovery broker?
They have some similarities in terms of the operational issues of where you put the hardware. They both have the advantage of putting less demand on the little nodes out in the edges of the network. The discovery relay is more lightweight because in the other picture, you really have a full-fledged discovery proxy that knows how to do the rewrite rules. It may have some application-specific optimizations in it. The benefit is it's only supporting one client, but you have to write all the code. In this case, there's less code running.
Go ahead.
There's
No, I don't. I think you're misunderstanding me.
Okay.
The discovery proxy now has been split up into these two pieces.
Yes.
And the piece that the client's talking to looks a lot like the discovery broker now.
From the client's point of view, it is using standard or standard-ish DNS, if you count the push notifications. It is using those standard-ish mechanisms to do its queries, and the client doesn't know whether it's talking to an authoritative server with a text file, a broker, a proxy. It could be talking to a broker that's talking to another broker that's talking to a proxy. The client, I mean, that's one of the benefits here is those arrows on the left-hand side are the same protocol in all cases.
I'm just thinking, I'm writing the discovery proxy, and I can't tell the difference between that and the discovery broker in this case.
The difference, the terms refer to what I might call functional units, not necessarily pieces of software. And I think if I describe the functions, that might make it clearer. The discovery proxy is a gateway from a unicast domain name to doing multicast DNS queries. So it is a unicast to multicast gateway. The discovery broker is a unicast to unicast gateway. And it exists to do a fan out so that one unicast query comes in for services.example.com, and that may be fanned out to 2, 3, 4, 5 individual queries on the other side. The discovery proxy never does a fan out. It's always a one-to-one. A query comes in for link1.example.com, and a query goes out on one link using multicast. So it is a one-to-one multicast to unicast to multicast translator. The broker is a one-to-many unicast to unicast fan-out multiplexer. Now, of course, these could end up being folded into one piece of software that is doing all of that under the covers. But in terms of the specifications, this is why I kind of made the allusion to Lego bricks, is it made sense to decompose those as separate logical functions. You can combine them in implementation, absolutely.
Thanks, Stuart. Yeah, we do need to move on. I think you had someone that wanted to say a couple of words about an implementation, just quickly.
Yes,
While you do that, we'll bring up the next. Oh, I can just sneak in your slides that Ted sent me.
Okay.
You don't need slides. You're just speaking, right?
Well, slides that I gave you were his slides.
Oh, okay.
Oh, you
Now,
did?
now it
Okay.
all makes
Right.
sense.
Yeah, hi, I'm Tokyo Helen Jaganton, and I sort of accidentally, independently implemented large parts of what Stuart was just talking about for the registration server.
So this is Tofu.
Yes.
Yeah. Oh, cool. Thank you.
So you've got about 2 minutes, I think.
Yes.
There we go. Full screen. You're off.
Next one. Yeah. Oh, I have.
Well, if you've only got 3 slides,
Okay,
I think.
yeah. So it's sort of it started out by me wanting to be able to find my devices in the network, and so what I wrote was a sort of DNS update proxy server that sits in front of an authoritative DNS server, and will do the first come first serve / trust on first use registration protocol, which is identical to what Stuart was talking about, and then. And then it will apply some policies. You can say only talk to these IP addresses, disallow certain names, disallow certain address ranges, and then on the other side, that proxy will speak normal T6 signed updates, or it can update unbound upstream servers. So you can also do, like, if you have it on your network, you can put internal addresses on one and global DNS on the other. And then the client will do most of the lookup dance. I had not read any of these drafts before implementing this, so I'll go and change that to support this. And it's about 2,500 lines to go. Next slide. So, and these are the main differences, and this was before I spoke to Stuart, so it's not entirely accurate anymore, but instead of the update leases, I just overload the TTL, which has some properties. I don't know if we can discuss that on the list later, whether or not. Like it allows you to do per record lifetime from the client to so they become the garbage collection times, whereas the update lease, that's for the whole thing. So there's some trade-offs there. It only speaks TCP, so that you can put this thing, theoretically this could live in the cloud, which I think when Julius was talking about, do you need Flash to implement this? Well, you cannot have it on your router, and you can just have it in the cloud. And then because if you use TCP, you get a connect back, so you don't have to worry about spoofing. And then there's a serve lookup, and it doesn't do the sleep proxying, and it doesn't do full DNS service discovery. So I created this just for A and AAA records. But other than that, it works, and I use it to sort of find my devices on my network with IPv6, and it goes into public DNS and so on. And it also has this, you can also use this once you've registered the key. So the client can tell the server how long is my key going to be around. So if it's a client that's only running in RAM and it knows it's going to go away, it can set a really short lifetime. But once you have the key, you can keep that key, and then you can, in principle, allow updates from anywhere. So I can have mylaptop.mydomain.com refer to an IP address at IETF, for example.
Great.
Which is an
Okay, thank you. Yeah, if you can send details of that to the list so people can go and take a look, that would be fantastic. So now we have Ted somewhere in my myriad of what do you get this one? Yeah.
Okay,
so we need to kind of speed up a little bit.
I'm going to go through this pretty quick because I think Stuart actually covered most of the concepts. My name is Ted Lemon, by the way. Is this thing supposed to work?
It's this one.
Sorry? Here we go. Basically, Stuart already explained all of this stuff. Let's see. So, trying to think. Let's see. Stuart covered that. Some key points that Stuart didn't mention in detail. So the discovery proxy That's the thing that accepts unicast queries and sends multicast queries. Discovery proxy, the modified discovery proxy that speaks to a relay proxy can still speak directly to the link if it's connected to it. It can also use a relay proxy to speak to the link. I expect that in the HomeNet use case, which is the one that mostly informed this for me, the relay proxy and the discovery proxy, sorry, the discovery relay and the discovery proxy will be separate devices even on the same HomeNet router. And of course, it can speak to links that it's not connected to using a relay. The discovery relay is really stupid. It doesn't do any translation. It just receives multicast packets from it receives the content of a multicast packet from the discovery proxy, and multicasts it on the specified link. When it gets multicasts from the link, it sends them to the discovery proxy. It's completely stateless. There isn't a request response kind of thing going on. It's just when it gets a multicast from the link, it sends it to whatever discovery proxies have subscribed to that link. And when it gets a multicast to send to a link, it sends it to the link. There's nothing more than that. Any caching that occurs happens in the discovery proxy. The discovery proxy talks to resolvers, even though the discovery relay is speaking unicast on the upstream side. Regular devices are not ever supposed to talk to it. And in fact, the draft has details about how to set up the operation of it so that doesn't happen, because it's kind of important that it doesn't happen. Yeah, so there's a ton of stuff about management in the draft that may seem like it's superficial or unnecessary, but this is to make this work cleanly requires clearly specifying how these devices are discovered, how they agree on the identities of the links, and all of those things. The management stuff, I have this like issue with the discovery relay and the discovery proxy, that it's not clear to me that you really need a discovery relay, right? Discovery relay is nice because it's smaller than a discovery proxy, but it adds a fair amount of complexity when you put in the discovery relay. However, that complexity wouldn't go away if you didn't have a discovery relay. In the automatic configuration case, you still need all of this management stuff, whether it's automatically configured through a management console or whatever. You still need to be able to say, so suppose so you've got devices that are you got the central device that answers queries, and you've got all of these routers on your network, each one of which may be a discovery relay, and you have to configure the central server to speak to the discovery relays. If you I lost my train of thought. The point is that this operational stuff needs to be specified, because it needs to be it needs to be the case that when you have a network with this kind of setup, that everything connects cleanly and you don't have anything left out, and you have a clean way of saying what connects to what. So that's why that management stuff is in the document. Has anybody read the document, by the way?
Well, that was a more general question we have. Who has read the complete set of documents that Stuart and Ted have put forward? So, okay. So I mean, the explanations here have been fantastic. I think it's, well, based on the fact that only 4 people have read them, it's a bit early to ask about a documents working group items. But yeah, I think we're going to have some good list discussion here now that we've had them introduced.
Yeah, I guess I don't... The main high-level stuff that Stuart presented is the stuff that I really wanted people to see. I wanted to call your attention to the management stuff, because it's more than half the document of the relay document. And the reason it doesn't necessarily belong in the relay document, but it seems like a good place to put it, because that sort of muxing and demuxing needs to be documented somewhere. And it would be a mistake to implement a relay that didn't support all of that muxing and demuxing. So hence, in the same document.
We talked before about a draft that talked about how you deploy this stuff, and that would be kind of part of that.
Yeah, I mean, it could go in a separate document. I mean, I think that's one of the questions that the working group should probably answer.
Yeah.
If it went in a separate document, obviously we'd have a document that described both how to manage the connection between discovery proxies and discovery relays, and also the connection between discovery proxies and discovery brokers. So that would be a few more moving parts,
Potentially,
but not a bad thing. But it's absolutely required to do the management stuff. If you don't do the management stuff, you're screwed.
No, definitely.
I'm going to make a quick request. We only have 10 minutes left, and I would really love to hear the stuff that Kerry has to
I think
present, so.
I'm done. So
Yes.
unless anybody
I
has
was about to
questions.
say we have 1 minute left on this. So, okay, great. Thanks, Ted. And Stuart, it's been, I think people have got a really good idea of the future items now. So the last item on the agenda is Kerry, who's going to, if I can find it, that's the mapping one, isn't it? It's going to talk about the interactions between the core resource discovery and Dnssd interop. We've also got Carsten in the room, which is great, to join any discussion. So you've got 10 minutes. So
Where do I point this thing? Anywhere?
so you've probably got the wrong one as well.
Right.
I don't know why there's two there. But, there you go. Any second now it should appear. Oh. Okay. That's that one.
Sure. All right. So I will do that. Basically, I'm not sure if we have a deliverable in this group, but I think we at least have the desire to sort of discuss this topic of interoperability between what the core working group is doing vis-a-vis resource discovery and what we're doing vis-a-vis service discovery. So I guess my job is to, I'm just going to start by asking you to suspend your disbelief till I get to the end of the talk. I'm going to try to make the case that at least at the level of RESTful API entry points, there's some commonality between resources and services. So anyway, this work, historic note, this work goes back actually about 6 years. Oh yeah, sorry. This work goes back about 6 years. Originally, when the core working group was chartered, they did not have a requirement to do their own discovery, but to demonstrate how it might be used with existing discovery mechanisms, namely Dnssd. My colleague Peter Vanderstock and I did a bunch of drafts in core talking about how this could be done, but eventually core decided to go in a different direction. And so as kind of a stopgap, we said, well, here is at least a way that you could translate between the two systems. And our motivation for that was to support heterogeneous environments, for example, HTTP servers or HTTP clients and CoAP servers, which could be enabled by something that core calls a cross proxy because of the similarities.
Better than what we had before. Sorry, carry on.
Of REST on both sides. So anyway, I hope to sort of explain or answer the why and what questions here, and then at the very end we'll just talk a little bit about how we propose to do this.
Sorry, Kerry.
I think the point I want to make on the first slide is that service discovery and resource discovery could be viewed as being complementary. Resources are potentially much finer grained than services. So potentially I could formulate a query in the resource discovery world for the B register of a color light bulb. But practically speaking, you really want to, come at that light bulb from some entry point, and then from there, using the tools of REST, namely hypertext links, get to other places that you might be interested in.
I think you're okay with the screens now, I think.
Yeah, okay, great.
Or do I need to press for you?
Next slide.
I'm not going to touch it now, it's working.
Okay. All right. Next slide after that. All right, so these are some of the basic background items. The main deliverable of the core working group was the CoAP constrained application protocol, building on other IoT standards that had come before, such as 6LoWPAN for supporting IPv6 over constrained links, and Ripple, which was the output of the role routing group. CoAP originally was REST with a UDP binding. An interesting side note there is that multicast RESTful operations are now possible. So the REST world basically is a set of architectural constraints You've got a world of servers, resources, and as I said earlier, you expect that a good RESTful implementation will allow you to explore it using hyperlinks. Takeaway from this slide is REST is the hammer. So they try to basically cast every other problem as a nail, and they look at the world as consisting of resources. Okay, so to talk a little bit about the resource discovery method that they came up with, it's based on core link format, which in turn is based on web linking. It makes use of these things called typed links. It's basically a relation between one link, which is typically the thing you're asking, what other links do you provide, to these other links, which are target links, and the relation between, the anchor and the target. Yes, between resources. Yeah, all right. That's what I meant. And optionally target attributes. So in the core world, you basically can query a server and say, give me all the links that you provide by doing a get operation to a well-known URI, which is .wellknown/core. Optionally, you can provide a query string, and what you should expect to get back from that is a set of links that match your query. So the core link format document, RFC 6690, defines some new target attributes. There's a thing called RT, which is the resource type. There's IF, which is, tell me about your interface specification, and the approximate size. Next slide. So as I said, if you consider a RESTful API entry point to be something like a service, then this is the sort of resource that you would want to potentially export from the core world into the Dnssd world. I should back up and say that as an efficiency, core is also positing the existence of resource directories, which is a repository of all this information from all the links that exist on that network. So the logical place for this mapping agent to contact would be the resource directory. And we have a draft that sort of describes this, that's a working group item over in the core working group. It basically defines two new target attributes. One is EXP, which is a hint that the server who registers that link says, I want this to be exported to a different naming system. The second thing that we have is an INS attribute, which is the instance of that. So there are other hints that can be provided, such as the domain that you wish to be registered in. If that's absent, then the mapping agent potentially has to figure out, is there a good candidate, for the domain to put this in, .local being probably the obvious default. Host name, if it doesn't already exist, has to be, sort of consed up in the DNS world. Next slide.
It's a bonus points for quad A and no A records. I like that.
All right, so don't take this too literally. There's probably mistakes in this example. In fact, I know there are. But the color coding is meant to sort of show how the mapping could potentially be done. So here, the mapping agent has basically done a query to the resource directory, and it says, give me everything, give me all of the, actually there's a pointer here somewhere. Give me all the links that have this EXP attribute set. And then it gets back, for example, a response where the resource type is OIC temperature, and this is one of the mistakes, should be OIC.r.temperature. But, and then the instance name is indoor temperature, and the interface type is, kind of a semantic tag, application-specific semantic tag that tells you how to operate on this thing. The resulting RRs is that a host name was synthesized if it wasn't provided. The quad A record is registered, and we end up with a service of type OIC, this is the thing that I presume would be registered with the service type registry. But then below that, the subtype of that would be a temperature sensor. And then we would basically take other things that have been provided, and they would be text value pairs that would be put into the text record. So that's basically it in a nutshell.
So we're almost out of time, but we can probably just stretch on a few minutes just if anyone's got any quick questions or comments on that. Thanks, Stuart. Kerry.
Thanks, Kerry. I have a question for, I'm Stuart Cheshire from Apple. For you, or maybe for Carsten, the OIC in that example, which is, in my parlance, the service type, in Core World, it's the resource type. Is that registered in the IANA service type registry?
There should be some sort of a namespace, I think, convention.
Well, with the link format, there are two registries. So the names that are under RT equals and the names that are under IF equals, they have a registry. And OIC, OCF as they're called now, has registered some 80 resource types there. So this is a name that is registered, but it's not a service, it's a resource.
But there would be no reason not to sort of like take the preamble part of the namespace of those resource types and register that in the service type registry.
So this could just be an RT, and this could be a rendition of the registered type, and it would work for everything. So you wouldn't have to invent a mapping here.
I'll let you go ahead.
Register every RT for a given SDO as a service. These have to be registered.
These have to be
These have to be registered,
These.
not those.
Right. So just register RT once.
The problem,
already have a
Carsten,
registry
is that
for
RT values can have dots in them, right? And so the question to Stuart is, where in the blue down below, where it's sub.oic.udp, is it a problem if OIC has a bunch of dot separated labels there?
Put _2c there.
Procedurally, it is a problem because the IANA, I mean, from a software standpoint, we could escape the dots, but the specification for the IANA service type registry says letters, digits, and hyphens, because that is sufficiently expressive. We're not going to run out of them. And when you ask for a string, you don't ask for a string with an ampersand in it. If you're trying to wholesale import names from somebody else's registry with a different set of rules, then they might not follow the existing IANA rules, and we'd either have to change the rules. I mean, that's a bit awkward to change the character set.
Exactly. Right. So that's the problem in at least procedure anyway with putting the entire RT into that position. The procedural issue with doing what Kerry has on there is, and of course, since as you mentioned, there's errors on the slide, the actual example that's registered is OIC.r.temperature, and so where is the r dot in here? And so I'm guessing it would be r.temperature dot underscore sub dot. In other words, the r is in the very left end. It's another sub label even beyond that, right? Or you have to escape it or whatever it is, right? And so the question is, how safe is it to assume that the leftmost label is the one that's special?
I guess we're probably assuming that the mapping agent has some sort of intelligence, but yeah. Otherwise, we might have to come up with some convention for doing this, which I think is a
I imagine there's going to be
first come, first serve in terms of conventions.
I'll make one last quick comment because we do need to wrap up. And I suspect this is a discussion I have to have with Carsten, and maybe we can do it offline. But for the minutes, I want to raise this issue so other people can think about it. To me, when I say a service, that is some entity on the network that you talk to with a protocol. You maybe tell it to do things or you ask it questions. And when Carsten talks about a resource, that's an entity on the network that you talk to with a protocol and you ask it questions or you tell it to do things. To me, it sounds like exactly the same thing, But every time I talk to the core people, and Carster's shaking his head right now, it's like, no, it's not a service, it's a resource. But the description of resource sounds like exactly the same words I used to describe a service. So I think it would help this discussion if we could actually figure out why a resource is not a service.
Certain, I guess that's my claim, is that certain resources quack like a duck. So.
Okay, thank you, Kerry and Stuart. Carsten, you just want to make one last final quick comment?
The answer to that, which I'm not going to give, is exactly the reason why we have this EXP thing there. So we can identify resources that are worth it being announced as services. So some may be, some may not be.
Yeah. So I think from the last meeting where we just had some people come together and chat, we've now got to the point where we've got a draft. I think it's been adopted by core, this draft, at least the naming suggests it has been, draft IETF core, blah, blah, blah.
Well, actually, the content of that draft has been part of the core resource directory for like 5 years now.
Oh, okay. Well, it's good it's now coming to light so we can discuss it. So I encourage more discussion of that. Thank you to everyone. Just to quickly wrap up on the actions, I think we've got a fairly clear idea of what Christian's doing from the hums and votes that we took, and I'll just confirm that on the list. Stuart stuff's and Ted stuff's a little bit early to adopt because only 4 people have read it so far, but I think the explanation here has been fantastic, and we're making some headway now on the interop here, which is great. So, do you want to wrap up?
Yeah, it's outgoing. Thank you all so much for your collaboration, goodwill, and willingness to move things forward. This working group has been a real treat to work with. We have just gotten down to it and gotten it done. It really, I applaud all of you.
Okay, so meeting closed. I think the plenary is in Congress 1 and 2 in 15 or 20 minutes.
One of these up here is.
Was there when we arrived? Oh. Okay, we knew it wasn't ours.
People asking questions, you guys trying to get in. Don't forget, there was something down there.
Yeah, can you unplug my power?
That's yours.
This one. Oh, it is. Is it unplugged? Thank you.